So in the previous video we have constrained this location and applied the load here, and this is the deformation, this is the animation which we got, and we also calculated the stresses. But if we somehow constrain this and apply in this and enforced displacement, what will be the result we will see, and how to do it in MSC Nastran, that we will also see. So just open HyperMesh and set the profile as set the solver interface as MSC Nastran, and then just go on and drag this BDF file here. By the way, this BDF file you can download it from the attachment also. And if you don't want to download it, we have just watched the previous video. We have exported this BDF file also. Just go on and click on open, so it will open it. I'll just go on here and set this seeded elements view. Yeah, so collectors are there. So I'll just go on here and do try to do this fix as make current, and just type SPC, and I will delete all other collectors. I don't want other collectors. And for SPC, I'll just go on here and go to analyze constraints, and just as these are solid elements, these are having only 3 degrees of freedom per node. I'll just constrain this 3 DOFs. So all this face nodes I'm constraining, create. So as you can see, this all face nodes are constrained now. Now here extend this bar in negative Z by 5 mm. So what I can do here is I can go on here and constraint again, and I will just go on here and free these constraints, and then in DUF3 I will just click here and I will type, as it is in negative Z direction, I can just go on here and type -5 first. Then for node, I'll click on this node. Okay. So this -5 means all these nodes will be displayed by -5. Uh, if somehow I apply force here, that means that force will be shared by all these nodes. That means that if there are thousands of this node in this phase, then force will be, if I apply 1000 newtons here, then force each node will have 1 Newton. But if I apply constraint of -5 mm, that means all nodes will be displayed by -5, all this dependent nodes. Okay, so now I can go to this loads, I can go to this load collector, and I can just change this name to enforced displacement 5 mm. Okay, and just I need this SPC card, so I can go on here and just select this SPC card. Actually, this SPC contains this all these constraints, this constraint also and this constraint also. Then I can just go on here and export this. So this export rod enforced displacement 5 mm. Just go on here and I will just unselect some of the comments. This you can unselect this all these things if you want. Even if you keep it, there will not be any issue. And then just go on and export this deck. So this deck is exported. If you can see here, so I'll close this one and then I'll go to here Nastran and just go on here and double click this and then just run this. So this solution is now completed. Whether we will see whether it is completed properly or there is some error. Just go on here in the log file and check. This analysis is started at this time and linear static solution analysis is completed. This time that means the solution is completed, and also we can open the F06 file and check for fatal. If there is no fatal, that means the analysis is completed here. So just I will close this and I will go to now hyperview. I will just delete this, clear this, sorry, and then I will go on here and just read the ODB file. You can read the PDF file in input file and you can read the OP2 here. Alternatively, I can just read the OP2 in both input and output. That will also work fine. Just go on here and yeah, and just animate this. So you can see here, I'll just scale this to 10x. So if you see here, there is some animation. It is we are just elongating it by 5 mm in this in negative z direction. Now I will just put here 1 and we'll see the displacement also. It should be 5 mm in this direction, near about 5 mm, and the z should be negative. Yeah, so it is z, it is -5 around, and now we can see the stresses also. So if you see the stress here, sigma zz should be dominant now. So 1 second. Yeah. Let me just do this none. Sigma zz should be dominant now. So I will just go on here and go to sigma zz. Okay. And now I can just go to measure here and go to element contour and pick any element. Now coming to the validation part, we know that the enforced displacement whatever we applied is 5 mm. So the original length of the bar is 1000 mm. So 5 divided by 1000 is nothing but 5 microns. Sorry, 5 divided by 1000 is nothing but 0.005 strain, that is engineering strain. And if we know that the Young's modulus of steel is 210 GPa, so stress is nothing but strain into Young's modulus. So if we multiply that, we will get 1050 ampere of stress. That is our nominal stress, and whatever we are getting is in FEA is nearly about 1052.023 MPa, which is very near to whatever we have calculated through our classical engineering mechanics equation. So whatever we have calculated through FEA is correct. Uh, yeah. So this is all about the how to apply and force displacement in MSC Nastran. Thank you. Have a great day. Bye.